Hello and welcome back to Introduction to Number Theory. In one of the previous videos, we saw that convergence of an infinite continued fraction have a limit as a sequence. But what if the continued fraction was obtained by taking a real number, an irrational number, say alpha, and then constructing a continued fraction for this alpha? A0 plus 1 over A1 plus 1 over A2 plus and so on. And will the limit of the convergence for this continued fraction, which we know as something that doesn't quite depend on alpha, will this limit be equal to alpha? Or should we say, will alpha be equal to this limit? Let's find out. So, we'll be interested in the limit of convergence of this continued fraction. So, consider one of these convergence. At step number n, we gain a n minus 1. Well, it's under the line. A n minus 1 plus, I hope you remember that when we turn an irrational number into a continued fraction, we all the time have some integers, a0 to a n minus 1, and something irrational here in the end. So I will denote this irrational thing here as beta, say. So this is an equality. This is a finite expression. It's not quite a continued fraction since not all of these elements are integer. But we can work with it. Now, notice that if we remove beta, then the remaining expression will be equal to Pn minus 1 over Qn minus 1, convergent to this continued fraction. And, well, beta is something irrational. If instead of beta we take 1 over an, well, just imagine for a second. If instead of beta over here we take 1 over an, then all this together with 1 over an instead of beta will form the next convergent, Pn over Qn. And we certainly understand that beta is less than 1 over n, 1 over an. So beta is, well, certainly greater than 0 and less than 1 over an. Let's study the function we're dealing with here. I mean the function f of x, which is equal to a0 plus 1 over a1 plus 1 over a2 and so on until we get to this step. Over here we have 1 over an minus 1 plus x. Well, what kind of function is this? Is it a polynomial? Is it a trigonometric function? Well, of course it's not trigonometric, and it also is not a polynomial. If we fold this expression into just one fraction, then it will be equal to some coefficient. Denote them bx plus c over bc dx plus, well, I don't want to take e because it's a constant, and I don't want to take f because it's already taken. A, B, C, D, E, F, G. I'll say plus G, where B, C, D, and G are some integers. Actually, we certainly know that D and G are positive integers. Well, B and C might not be positive because of A0, which can be negative. Okay, so A0 can be negative, but all of the others A's must be positive integers. So D and G belong to the set of positive integers, and B and C belong just to the set of integers. What can we say about this function? Well, it's a well-known function. It's a hyperbole, so it consists of two branches. But since we're dealing with positive D and positive G, and X is also positive because beta, which we have here, is between 0 and 1 over an. So we can say that X is greater, well, let it be greater or equal to 0. In this case, this function is either decreasing or increasing. Well, which one of these? So f is either strictly increasing or strictly decreasing. We cannot say which of these actually holds if we know nothing about f. But I can tell you that this actually depends on the parity of n. It doesn't matter now how the parity of n influences the direction of monotonian f, but all we need to know that f is either increasing or decreasing, because from this it follows that f of beta is somewhere between f of 0 and f of 1 over an. And if we take a look at this expression here, then we'll understand that f of 0 is equal to Pn minus 1 over Qn minus 1. F of 1 over an is equal to Pn over Qn. And of course, f of beta is equal to alpha. So we understand that alpha is somewhere between, it's somewhere between these two convergents. So, since we understand that the limit of the convergence is also between two neighbor convergents, because you remember, right? Because the convergents go 0, 1, 2, 3, 4, 5, and the limit is somewhere in between those with even numbers and those with odd numbers. So this limit is between any two pairs of neighbor convergence. Alpha is also between two neighbor convergence for any n. n is absolutely arbitrary here. So from this it follows that this limit is actually equal to alpha. So our value of the infinite continued fraction, which we defined in the previous video, is equal to the irrational number, which is decomposed into the continuous fraction. So everything's okay here.